Alrighty, this is going on page 113 when we're done. And this that's on the front here is actually the last thing we're going to do. So I want you to open this all the way up and look at the other side. And look at this circle here. Okay, so this circle is graphed on the coordinate plane. The center of the circle is at the origin, right? And we're going to look at angles on the circle and in the coordinate plane. And if you have an angle in the coordinate plane in standard position, then the vertex of the angle is at the origin, right? And one of the sides of the angle is on the positive x-axis, like right here. Okay, so if I have a closed angle here on the positive x-axis, then it's going to start to open up in this direction. And so if my angle opened up this much, it would be a 30-degree angle. If it opened up this much, 45, 60, 90, and so forth. Okay, so we start here, and the angle opens up counterclockwise all the way around to 360. Okay, does that make sense to you? It's one reason why the rotations that we do are counterclockwise unless you're told otherwise, because that's how the angles work in the coordinate plane. Plus, that's also why your quadrants are numbered like they're numbered. Do you ever think it was kind of weird the way the numbers work on the quadrants? And at first it's hard to remember and understand why. Well, when the angles start here, you open up, you go through this quadrant first. This is the second quadrant you go through. This is the third. This is the fourth. That's why it's quadrant 1, 2, 3, and 4. Does that make sense to you? So they make a little bit more sense once you start doing some more stuff with them. All right. So we're going to look at these. The title of these notes is actually Radians in the Unit Circle. So the word radians you've heard before in here. It's not radius, it's radians. So where have you heard the word radians? Or seen it multiple times? Where do radians come into play? Do you know what to do with radians? Do you know what they are? Yeah, okay, you remember the word. So do you know what they are? No. Do you know what to do with them? No. Okay, so the times you heard the words was the times you said, we don't know what to do with these, so we don't want them. So where were you dealing with that? Where did the radians come into play?
Oh, was that for the shape? Wasn't that when the shape was like that?
No. On the calculator. Yes, you had to switch it out of radian mode because you don't know what radians are, right? Right? On your calculator, you got to put it in degree mode because you don't know what radians are. That's where you've seen the word radians before, right? Because we don't know what they are. We don't want a radians. We're not using that. We're using degrees. So we can measure our angles in degrees or radians, but you didn't know what radians were. Today, we're going to look at what radians are. Okay? It's a different way to measure that 30-degree, 45, 60-degree angle, and so forth and so on. Okay? Right now, you know, we are just supposed to touch on the very minor bit of radians. When you get into pre-cal, you start using radians a whole lot more than you do degrees. And then when you get into calculus and beyond, you're pretty much using nothing but radians and rarely ever talk about degrees. So it's kind of a slow shift into what you need to understand here. So in order to figure out how all of this works, I'm going to give you one of these things today. Y'all ever use Binderoos? You've seen Binderoos like on infomercials or whatever. A Binderoo is they're also called wiki sticks. Wiki sticks are really expensive, and I got a really good deal on Binderoos one day, so I bought a bunch of SpongeBob Binderoos so that we could use them. But it's basically just a piece of string that's dipped in wax so that you can bend it and it stays like you want it. So it's not just a piece of string that will do its own thing. Okay, so you each need a Binderoo. Give you. Binderoo, I know. I may end up calling it Wiki Sticks by accident in the middle because they are the same thing. It's like a name brand thing. So, but Binderoos, these are technically Binderoos, what you have. So you each need one. Do not eat them. Okay? And somebody earlier said, well, have you had any? Why do you have to say that? Well, because I teach freshmen, and so I know to say, don't eat them. Okay, and then people, ooh, these look appetizing. Okay, I don't care how good they look. They're not edible. Don't eat them. Don't chew on them. Nothing. But I want you to take your ruler. Okay, you should know the difference between centimeters and inches, and measure accurately your little Binderoo in centimeters. Measure your Binderoo in centimeters. Okay, if you're telling me 7.5 and I come check, it better really be at 7.5 because it probably isn't. 7.4 is where it really should be. Now, I cut these with a kitchen knife during fourth period, so it is possible that they're off a little, but it's more likely they're too short instead of too long. So double check. If you really, really think it's 7.5, let me know. I'll come double check that you don't have something that's wrong. Okay. 7.2. Okay, well, I'll definitely come check yours. Okay, so when I put it on the ruler there, see right there is 0. It does not go to 7.5. Okay. You have 7 point what?
I can stretch it out.
Well, no, stretch it out. I wanted to see what you actually had. Not really. You can't. Well, you can sort of squish some of the wax out, but you can't really stretch it because it's a piece of string. Well, it's 7.4 now if you did stretch it. Yeah, yours might be a little. Let's see if we can squish it. Let me give you a different one because yours is pretty close to something. Yours is, it's kind of actually in between the two, but it's enough to make a difference. Let's see if this one. Okay, that's more 7.4. All right. And yours is kind of close to 7.5 too. It's kind of like in between the two. All right. There you go. That one's 7.4. All right. So now I want you to take your bindaroo and you're going to lay it down on your circle right here at the origin. So it represents what part of your circle? The radius, okay? Now, when you lay this down on your paper, be careful not to squish it too much because you can kind of you can squish it down a little bit. So, but you squish it too much, you might be squishing more wax out the ends and making it longer and not realizing it. You with me? So if you actually do that, just like squish the ends back in, you'll be fine. All right, so your bindaroo is the length of your radius. So the radius of your circle is 1 bindaroo, right? We're going to use bindaroos as a unit today because you can just make up your own units, whatever. It's 1 bindaroo. Then you're going to take this and you will take it off the radius and you're going to put it right here on this point and mold it around your circle and then mark where it ends. But be careful not to mark like way past where it ends. Like you may even need to lift it up a little bit to kind of, mark exactly where you actually stop. And then you're going to pick it up and start where you marked and then work your way around and mark it again. And then just keep going all the way around your circle. It will not come out to an even number, so I'll tell you that much. And once you've gone around once you've gone around one full rotation, then I want you to start from the beginning and do it again and kind of double check yourself. But when you stop, your last full one should be somewhere like right about there. Don't put it down here and then mark it again up here. That doesn't make any sense. You only do however many full ones you can make and then start over from the same spot and just double check your measurements. Because a lot of times when you go back around the second time, you're like, oh, dang, I shouldn't have put it there. And you can kind of adjust yourself a little bit. Okay, so do you understand the instructions at this point? Okay, so I'm going to give you a minute to work on that. All right, so you've marked it all the way around and ended somewhere right about here, right? I mean, I didn't measure mine. I just kind of threw a little line up here. But you have some left over that you could not put a full bindaroo on. So on number 1, it says how many times does the radius, because remember your bindaroo represents the radius, how many times does the radius of the circle go around the circle? So how many times does it go around? A little over 6. Okay, so we can say a little more than, because there were 6 full ones, right? A little more than 6. Now, I would like to know really like how much more than 6. So I want to know how much of that bindaroo would fit right here. Okay, so you can set up a proportion, right? So a proportion, remember we can use our bindaroos as units. So for every 1 bindaroo, there is 7.4 centimeters. So I want to know how many bindaroos there are in a certain number of centimeters that we're going to come up with here in just a second. Okay? So 1 bindaroo for every 7.4 centimeters, how many bindaroos in however many centimeters this is going to be. So in order to figure out how much this is going to be, you're going to take your bindaroo and put it right there at the end, like you would have to go around, right? Obviously mine doesn't really fit on my circle up here, but, and it's going to overlap that point right there, right? So then with your pencil, you're going to mark that on your bindaroo itself. You mark that point, and you can like literally like push into it if you want to, because you know, with your pencil you can, so that you have like a little hole there or something, so that you know how long this is on your bindaroo. Does that make sense to you? Everybody understand how to mark that? Then once you have that marked, then you're going to measure that accurately in centimeters on your ruler. And whatever number you come up with is the number that you put right here. You got what? Okay. You got 1.5? 1.5? 1.6? Okay. Okay, whatever you got, write it right here. What did you get? 1.5. Belen, you got 2? Yes. Okay. So does everybody have somewhere between 1.5 and 2? Anybody have anything less than 1.5? What do you have? 1.2? Okay. Anybody have more than 2? Okay, most people are in between those two. All right. So what do y'all have? 1.5? A lot of people with 1.5. What do you have? You got 2? Okay. 1.6? 1.5? What did you say you got?
I had less than that, and like I redid it, and it got lower. I don't know what I did.
Okay. What did y'all get? What did you get, Jose? 1.5. And what did you get, V? What? 1.1? Okay. All right. So let's see. I'm going to pick somewhere in there. Somebody said 1.8, right? It was 1.8. Okay. I'm going to use Jackie's. So don't write down what I'm writing down. I'm just writing down Jackie's. It is okay that we all have something different. It is fine. I'm not saying that Jackie's is right and everybody else is wrong. Okay. So I'm going to use 1.8 right here. So in order to figure this out, now I set this up as a proportion, which it doesn't necessarily have to be, but it is a proportional relationship. Would you agree with that? So 1 over 7.4 is x bindaroos over 1.8. But since I just want to know how much of the bindaroo it is, couldn't I just take the 1.8 and divide it by the 7.4? Isn't that the same thing? It's the same thing as when I cross multiply, right? So don't take 1.8 unless that's what you got. You take your number, whatever it is, and you divide it by 7.4, and that means you got 6 full rotations, right? So it is 6 point something. So the something is what you're about to get on your calculator. Whatever you take this number divided by 7.4, that's going to give you these 3 decimal places right there. So figure out, there's one calculator on your table that you can share. Well, 1.8 times 1 is how you solve a proportion, and then divide by 7.4, yeah. Okay. So I'm going to write down what Jackie had. You write down whatever you had, okay? It doesn't matter. You're just dividing. Okay? So we should all be close to 6.2-ish, right? Everybody in that ballpark, no matter what you had divided out? Okay. So you're all about 6.2-ish. So it takes 6.2 bindaroo, 6.2 and some, ish, bindaroos to go around your circle. You agree with that? And this is your bindaroo unit. Okay. So let's pause on the bindaroo stuff for just a second. Let's go to another definition, and then I'm going to pull all this stuff together. So a definition that we need here is of a unit circle. So a unit circle. The unit circle is going to become your best friend or your worst enemy when you get to pre-cal, depending on whether or not you actually learn it. You have to learn it, you have to love it, you have to know it like the back of your hand. It is not something that you can just decide, I'll just not make 100 on this quiz and it'll be fine. Because you use it all the time and you will struggle. And one of the things that the kids struggle with the most in calculus, besides algebra, is the unit circle. Now, I'm not going to make you memorize anything right now because you don't use it at all in Algebra 2. So it just, it's not even going to matter there for you. But then come back around to pre-cal and you got to know it like it's your best friend. So we're going to look at it. We're going to know how to find stuff, but whether or not you actually know it right now and can just rattle it off, it doesn't really matter. But a unit circle, a unit circle in general is a circle with a radius of 1 unit. So this is a unit circle because it has the radius of 1 unit. My units just happen to be Binderoos, right? So we have a unit circle because our radius is 1 Binderoo. Okay, it's 1 unit. So then it says, what is the exact circumference of the unit circle? Well, what's the circumference of any circle? How do you find that? 2 pi r, okay? 2 pi r. So since this is a unit circle, what is my radius? This is a super easy question. What's the radius? 1. A unit circle is a circle with a radius of 1. My radius is 1. So the circumference here is 2 pi units. That is the exact circumference of this circle, which is the distance around the circle. We all agree with that? Now, if I was to get the decimal, it says exact here, but if I was to get the decimal approximation of this, that is 6.283 units. Okay, that's the decimal approximation there. Okay, you did. So if you go to question 3 here, it says, what is the approximate circumference of your unit circle? Whatever you wrote here is what you write right here. And don't just copy my number down. You put your own, which is most likely different than mine, and that's okay. 6.243 units. Everybody good with that? That's the length all the way around the circle. It's the circumference of your circle in Binderoo units. Yes? Okay, so then it says, what is the length of the semicircle? So how could I figure that out from what I have? Divided by 2. Now, technically, we should take the decimal that was there and before it was rounded, but I deliberately just put one calculator on your table to make it easier, so I'm going to let you cheat on that just a little bit. And just take whatever your rounded number is and divide it by 2, and that's fine. Okay, it's close enough because this is all a little bit far off anyway. So just take whatever your number is here and divide it by 2. Which may be mine, but only if you ended up with 1.8 earlier. But it should be, again, in the same ballpark, yes? We're all in the same ballpark? Okay, good. So now, question 5, because I, just decided we didn't need a question 4, says, how does your answer in number 3 compare to number 2? So how does this number compare to your number here? Is it pretty close? Yes. Okay, so it's close. That's all we're looking for, right? So what can account for the difference? Well, how about the fact that we're using Binderoos, right? We're using Binderoos. These are not exactly, super scientific tools that I have given you. You're not going to go work in some engineering firm and, say, I'm sorry, I'm out of Binderoos. I cannot finish the project that I have to, yeah. So, but it's getting us what we need, right? Okay, easier than some other things to do. So now let's think about what all this means. For my unit circle, the distance around the circle is 2 pi. Does that make sense to you? And the distance from here to here, or the arc length for the semicircle, is just pi. You see how these are pretty darn close? Okay, and if we were really way more accurate with these, if I had been, because I had been in the past, but if we were way more accurate with these, we would have gotten something even closer. But that's still pretty close for using Binderoos that were not cut very accurately, most likely. Okay, we all good so far? So here's what we have. This one radius, you took this, you bent this around your circle to right here. One radius is 1 radian, okay? So although this is 30 degrees, from here to here is 1 radian. 1 radian is about 57 degrees, and that should hit it right about 57 degrees for you on your circle. Would you agree with that? So all the way around the circle is 360 degrees, or 2 pi radians, because it's an arc length type of relationship. Technically, it's the arc length divided by the radius, but when you have a unit circle, your radius is 1, so you don't have to worry about it. If my radius was 2, then wouldn't this arc length be twice as long? So I just take the arc length divided by the radius, which is 2, and then I still end up with 1 radian, okay? So your 30 degrees has a radian measure that matches it. Now let's just think about what these would be. If this is 0, 180 is pi radians, right? Then what would 90 be? 1/2 pi, but it would be pi over 2. It would be pi halves is the way you write it. But does that make sense? So this is 0 and pi, so this would be pi halves. This all the way around is 2 pi. So 45 degrees is pi fourths in radians. 30 is pi sixths. 60 is pi thirds. Those are things that you have to be able to just rattle off and know once you're, not now, but once you're in pre-cal. And then the ordered pairs also, you have to just know what those are. I don't expect you to just know any of that at this point. That is not what the point of this in geometry is. It's just to expose you to it and for us to understand how to convert. What you should be able to do at this point, though, is come up with some of the ordered pairs. So if this radius is 1 unit, what's this ordered pair right here? Don't overthink it. It is a super easy question. 1, 0. Right? What is this ordered pair up here? 0, 1. This one is -1, 0. And then this one down here is 0, -1. Now, at this point, that's the only ordered pairs that I expect you to be able to figure out, or even the only ones I actually want you to label. I decided to go ahead and leave these little ordered pairs here like this. We're not going to fill them in right now. I may not have you fill them in at all, but I want you to know that they're ordered pairs that you can find and they totally make sense where they come from. I may at least show you that one day, even if we don't come back and do a full lesson. But what you should know, just based on what's here, is all the x values that fall in here, they'd all have to be less than 1, right? And all the y values would also have to be less than 1. So they come out to fractions that you won't like, but it's fine. I mean, it really makes sense in the end. Okay, we all good so far? So 0 degrees, 0 radians. 360 degrees, 2 pi radians. 180 degrees, pi radians. Okay, and then the rest just comes from that. We all okay so far? Okay, so let's go back to the front and let's kind of bring all this together. Alrighty, so a radian measure of an angle is the ratio of the length of an arc intercepted by a central angle and the radius of the circle. And that's the concept you're expected to leave geometry with, because we talk about arc length in here. Whatever the arc length is, I mean, we could figure out these arc lengths based on 7.4 centimeters if we wanted to. And if we found that arc length, then we divide it by the radius, which is 7.4, then we'd end up with 1 radian. So that arc length right here on your circle that you have, it's ginormous right now, but that's fine. So literally on your piece of paper, from this point here, this arc length is 7.4 centimeters, because that's how much the radius is. And when you take this arc length of 7.4 and you divide it by the radius, which is 7.4, you get 1 radian. And that's where your 1 radian is. Okay? All right. So, exactly how many radians are in half a circle? Pi. Good. It's pi. And then exactly how many degrees are in half a circle? 180. And if you can understand that 180 goes with pi, you're good to go on the rest of it. Okay? The conversions become very, very simple. So if I want to convert from degrees to radians. Okay? It's a proportional relationship. For every pi radians, there's 180 degrees. That would be equal to whatever radians I would be dealing with over whatever degrees I would be dealing with. Now, I want to convert from degrees to radians, which means that I want radians in the end. So when I look at this little proportion I have set up here, what could I do to get radians by itself? Multiply both sides by degrees. Would you agree with that? I mean, it's very simple to solve that out there. Okay, so when I do that, I end up with degrees times pi over 180 and that's equal to radians. Does that make sense to you? Whatever degrees you have, whatever the angle is, you multiply it by pi over 180, that's going to give you the radian version. You with me on that? So if I'm going to convert from degrees to radians, I take the degrees that I have, whatever they might be, and I multiply by pi over 180. If I want to convert from radians to degrees, if I think about for every 180 degrees, there are pi radians. So that's degrees over radians. Well, if I'm looking for degrees, to get degrees by itself, I can multiply both sides by radians. So the radians times 180 over pi, that leaves me with degrees. So I take the radians that I have and I multiply by, my pen's being weird, 180 over pi. It's very difficult to actually multiply backwards. It's easy to say it backwards and to maybe think it backwards. But look, if I'm trying to get radians, I have degrees, I want radians. That means there's some sort of pi in my measurement. That's why I need it in the numerator so I can multiply it in. If I have radians and I want degrees, I got to get the pi out of there. That's why it has to be in the denominator so things cancel out. Okay, so if you do it backwards, you're going to end up with like a pi squared and something's not right. It'll be real obvious that you're wrong. Okay, any questions at this point? All right, so I'm going to draw a little picture to help us with the rest, like right here. But if you draw yours right here, when you glue it in, you won't be able to see it. And there's a lot crammed on this little page because I was trying to put it all in one place, but it not be so tiny you couldn't read it. But there's not a whole lot of extra space. Usually there's space at the top and the bottom. You have some space right here. So what I'm going to draw, you're going to draw small, but draw it right here. But I'm going to draw mine down there so I don't have to scroll up and down. But you'll be able to see yours. Does that make sense? So you draw yours here. I'm going to draw mine right here. Okay. So you're just going to draw a little x and y axis. This is 0 degrees. This is 90. This is 180. And this is 270. And I know that's not a whole lot of space to do this, but it's okay. It doesn't have to be the best picture in the world either. Then everything else we do will be kind of within this. So you can draw a circle. I would suggest you draw it as, maybe as big as you can in the little space that you have. And then this is quadrants 1, 2, 3, and 4. And hopefully you can at least get a tiny picture that you can refer to. But you don't really have to have it to do what we're doing. I just think it helps to make it make sense. Okay, so then number 1 says that we are going to convert each degree measure to a radian measure and give the quadrant. So we'll actually do the quadrant first. If I'm going to start here at 0, and I rotate 120 degrees, which quadrant do I end up in? 2. Okay, so I end up in the second quadrant. Then I'm going to convert. I am changing degrees to radians, so I'm going to take this 120, and I'm going to multiply it by pi over 180. The pi is in the numerator because I want a pi in my answer to get me radians. I can put the 120 over 1. I can multiply straight across to give me 120 pi over 180. Then I can reduce, right? I can knock out the zeros. And then what would that reduce to? Okay, so what do I write down? 2 pi over 3. Listen very carefully. It is 2 pi thirds. It is not 2/3 times pi. I, nor anyone else, is going to accept that as an okay answer. Excuse me. I've been trying to explain to y'all that these things need to be all in one fraction. Sometimes it matters and sometimes it doesn't. It does with radians. You would never see radians written as 2/3 pi. It is 2 pi over 3. Okay, we good? All right, so then this 245 degrees, what quadrant would I end up in? Third. Okay, so I'd be in quadrant 3. I would take 245 multiply it by pi over 180 to get the pi in there. Put that over 1, and I can multiply straight across. So I don't have any zeros to knock out here, but what can I divide both of them by? 5. So 5 goes into 245. It goes into 24 4 times, right? With 4 left over, so it'd be 45. And then that goes in there 9 times, so I get 49 pi over. How many times does 5 go into 180? 36. Can I reduce it anymore? No, because the only thing that divides into 49 is 7 and 7, and so it doesn't work. So 245 degrees is the same as 49 pi over 36 radians. 20 degrees, what quadrant would I be in? First quadrant. Okay, and then that's going to give me 20 times pi over 180. That over 1, so I get 20 pi over 180. What does that reduce to? Pi over 9. Yes. Pi 9ths. Okay. Everybody good so far? Okay, so that's converting degrees to radians. Now we're going to convert, it says convert each radian measure to a degree measure and graph. Now we're not going to graph today. We're going to talk about the graph. The graphing and some other things tomorrow, but we are going to go ahead and convert these. Okay, so to convert this, 3 pi fourths, I'm converting it from radians to degrees. So now I'm multiplying by 180 over pi so that the pi's will cancel out, right? And then can I reduce some more before I multiply? Yeah, the 4 and the 180. To divide something by 4, it's easy. You divide it by 2 and divide it by 2 again. So what's 180 divided by 2? 90. And 90 divided by 2 is 45. So it does go in there evenly. 4 goes into 4 once. It goes into 180 45 times. So you get 3 times 45. So 3 times 40 plus 3 times 5. And what do you get? 3 times 40 is 120. 3 times 5 is 15, so you get 130. Everybody okay with that? So then 11 pi fourths, I need it in degrees, so I'm going to multiply by 180 over pi. So my pi's cancel out. 4 happens to be in the denominator again. It's not always 4 in the denominator. I just put 2 in a row that had that. So I already know that, yeah, it divides evenly. So it goes into 180 45 times. So I end up with 11 times 45, which is easy because you can do 10 times 45 and add 1 more, right? What's 10 times 45? 450. You add another 45 and you get 495, which seems like a strange angle measure, right? But as you look at what's happening in the coordinate plane, it's not so weird. I can start here. I can go around 360 degrees, but then I just keep going to end up where I want to be. Okay, so that's what's happening there. All right, so this negative pi thirds, I'm going to multiply that by 180 over pi. I'll let you finish that one up while I hand out the homework, and then I'll wrap up what we're going to do today. All right, so here the pi's cancel out, right? And I can reduce that. What does this reduce down to? Negative 60 degrees. Now, negative angles you used to think didn't exist. I've told you a few times that they do exist, but they don't necessarily make sense to you. You're not going to get a negative 60 degrees in a polygon or anything like that at this point. But because I did things a little bit out of order this year, I had to tell you some of this stuff when we were doing rotations. What do the negative angles actually tell me I'm doing? Going clockwise. Good. So this counterclockwise is all my positive angle measures, right? But that negative angle measure, I'm going counterclockwise. I'm going clockwise. So that means that negative 60 degrees, it's not in the first quadrant. It's actually in the fourth quadrant. And negative 60 degrees would be the same as a positive what? 300 degrees, right? It's just like running the opposite way around the track. We can both end up in the same spot. We're just going in different directions, okay? And we'll look a little bit more about that tomorrow and graph them and whatnot. Right now, I've given you the assignment. Don't go trying to graph anything. The only thing I want you to do to get started on this is converting. You can convert from radians to degrees and degrees to radians, and then we'll finish all this up tomorrow, okay? So take your little wiki stick. You can just put it inside your notes, put it right inside the crease. It'll stay there just fine, and then just hang on to that. And then you have some time so you can go ahead and get started on converting.